Alright guys, let's talk about complex, right here, complex and imaginary numbers. In this video I'm just going to give you an explanation of what they are, and in the next video we'll explain some of the rules that are associated with complex and imaginary numbers, and then in the videos after that we will demonstrate how to solve some problems using complex and imaginary numbers. So let's get started. So before we get into, even though it says complex first, we're going to actually start with imaginary I. Okay, imaginary I is a number, a value, a theoretical number, a constant term that is always equal to the square root of -1. You might say to yourself, what's so special about that? Well, let's take a step back and remember when we probably learned this in basic arithmetic, even before algebra, so let's just have a refresher. A negative number multiplied by a negative number equals a positive. Alright? We all remember that. A positive number multiplied by a positive number equals a positive number. Now, remember, what does this, I'm going to circle it right here, what does this radical tell us to do? And what does it say? When there's no index of the root written here, we assume 2, right? And this is the radicand, right? So what it's telling us is that some value, in this case I, multiplied by itself is going to equal -1. Well, we just discussed that if you have a value and you multiply it against itself, it can't equal a negative, right? Because if it's a negative number, let's say -n, and we square it, that is equal to -n multiplied by -n, and that has to equal some positive value. And if it's a positive n multiplied by another positive n, it has to equal some positive value. This is telling us that I can be multiplied against itself and give us a -1. And just a -1. No other number. It isn't going to be -3, it isn't going to be -4. It's only going to be -1. And that's really handy because 1, it is the multiplicative identity, right? So that means that we can use that I to create other negative square roots, right? So that can be very useful and handy. Okay, let's talk about that now. We're moving into complex numbers already. So a complex number utilizes an imaginary number. It is made up of a plus bi. Okay, that's the form of a complex number. Now, this part gets a little confusing because I'm going to say real number and real part, but let's focus first. Real number, real number, real part. So that is the real part, the A. Bi is the imaginary part. And it sounds kind of rudimentary or simplistic, but that's really what it's called. The real part, the imaginary part, and A and B are both made up of real numbers. I is, of course, equal to the square root of -1, right? So we can see right here when B is not 0, we're multiplying it by the multiplicative identity, sort of, the square root of -1, right? A negative square root multiplicative identity, so we can alter that from the square root of -1 to some other value. Okay, that's where the B function comes in. Now, if B is 0, then all we're left with is a real number. A is 0, all we're left with is the imaginary part. If we have both parts, we have what's called a complex number. Alright, so that's an introduction as to what complex numbers are, what imaginary numbers are. In the next video, we're going to talk about the rules that are associated with them, and we'll do some problems.